All right, here's example 2. So we did our derivatives. Now let's look and see what an integral looks like. So I'm going to integrate here from 0 to 4 of x over x squared plus 9 dx. Now, when you integrate, all right, so anytime you integrate, your go-to method is a u substitution. If you need more practice with a u substitution, come to my office. We will practice that. Get extra examples out of chapter 5 in the book. You can practice that, but you have to know how to u sub. So my expectation is that you already know how to do that and we can move forward. Now I am going to give you some tips and tricks here if you don't know them already. Here are things to look for. I have x squared plus 9 in the denominator. So when you do your u sub, you go for the quote-unquote crazy thing. You can't see me air quoting, but that's what I'm doing. You go for the crazy thing, and in this instance, it is the denominator. A lot of times also, you go for what has the highest exponent. That's another good tip that you can look for. These are things to look for, but then you decide what works best. And here, this x squared plus 9, and then I can look at my numerator as 1 degree less. That's another good tip off, right? Okay, so my u here is going to be x squared plus 9, and you do need to write it off to the side. Then your du is 2x dx. Make sure you have that dx on there. This is a differential. Quit being lazy with your notation. And I'm here to tell you, next semester in Calc 3, you can't be lazy. Right now, we're only dealing in terms of a single variable. When you have multiple integration, it's going to make a huge impact on you. So get used to it now with these wimpy little problems. Okay, I'll hop off of my soapbox. I'm sure I'll get back up there at some point, but for now, I'll hop back down. So I'm just looking at this as an x dx. Let me change my color. This is an x dx, which means all I need is an x dx over here to sub in. So I'm going to divide both sides by 2, get a 1/2 du x dx. Now I know there are other ways to do this. Some people replace and just solve for the dx, replace that. That's fine. That's fine. As long as you are mathematically correct, I'm okay with that. My preference is this because when we do trig subs, it's not going to work out so nice in that method that you use. All right? So I know what's coming, so then that's what makes this happen. So I have x dx here, and I have my 1/2 du. So I'm going to put that, I always put that in front also, just throw that 1/2 in front. And then I get 1 over u du. Because my u is replaced here, this is replaced with a 1/2 du. So my du and the 1/2. This is a definite integral. Change your bounds. Do you have to change your bounds? I'm going to say yes. Now, mathematically, you can pull it off without changing it in these, again, these wimpy little problems here. When we do multiple u subs within the same problem, you will have to change your bounds. So again, get used to doing it correctly and your life will be easier. All right, so I'm going to make you change your bounds because I know what's coming. You'll thank me later. So when x is equal to 4, right, I'm going to take this 4 and plug it in, and u is 25. At x is equal to 0, and I plug that in, u is 9. So this is going from 9 to 25. All right, do your thing. I've got 1/2 natural logs of u. Remember, that's in absolute value in the fundamental theorem of calculus because it's a definite integral. Then you plug it in. I like to just leave that 1/2 in front. I now have the natural log here of 25 minus the natural log of 9. Now, when you have things that are nice like this, use your logarithmic properties and simplify this and work it down. With this minus sign in there, I'm going to go ahead. You could distribute that 1/2 if you wanted, or do this. I don't know. I guess really it's your prerogative because there's a couple ways to pull this off. I'm going to go ahead and take it 25 over 9. And then I'm going to take this 1/2 and bring it up here as an exponent. So what I really have is the natural log here, the square root of 25 over 9. So my final answer is the natural log of 5/3. You see that? Okay. So with the fundamental theorem of calculus, then you're breaking those down, right? And working it out that way. Right? Integration. So we've done derivatives, and then we can do our integration. Okay. Good job.